Meteors and meteorites. Meteors and meteorites. Focus question. Why is it important to study meteors? The sky is falling. The morning of April 22nd, 2012 began quietly. Suddenly, a ball of fire streaked through the sky over Nevada and California. Hundreds of people on the ground reported seeing the object passing high overhead. Many also heard a loud boom and said that their windows shook. The fast-moving ball of fire shone brightly as it raced through the sunny morning sky. Moments later, the object exploded in the air northeast of Sacramento, California, scattering pieces of itself over a wide area. The flying object that lit up the sky that morning was a hunk of rock from space, a meteor. The meteor broke into pieces over an area of California where the famous gold rush of 1849 began. The minivan-sized meteor's explosion set off a second gold rush of sorts as thousands of treasure seekers flocked to the area to look for meteorites, or pieces of the meteor, worth more than their weight in gold. Many scientists also rushed to the scene, hoping to recover meteorites that might help them learn more about the origins of our solar system. The effort soon paid off as scientists and amateurs alike quickly found pieces of meteors. Tests revealed that the rocks came from a rare kind of meteor that might be 4.5 billion years old as our solar system. Comets, asteroids, and meteoroids. Where did the California meteor come from? Outer space is full of objects left over from the time when the planets in our solar system formed. Comets, asteroids, and meteoroids are three different kinds of these leftovers. Comets are dirty snowballs. They are huge lumps of dirt and rock mixed in with frozen water and gases. Most comets travel through the Kuiper Belt, an area of our solar system located beyond the planets. Asteroids are rocks that range from about the size of a school bus to as large as a small moon. Asteroids mainly orbit the Sun in the asteroid belt, which is between Mars and Jupiter. Meteoroids are rocks as such smaller than comets and asteroids. Some are no bigger than a speck of sand. Others are as large as boulders. A meteoroid becomes a meteor when it hits Earth's atmosphere. We see meteors and streaks of light racing through the sky, shooting stars. When a meteor hits Earth's surface, scientists call it a meteorite. Meteorites are likely any rocks on Earth. As our solar system originally took shape, bits of asteroids and planets broke apart. The rocks flew through outer space as meteoroids. Some are still crashing into Earth as meteorites. By studying these space rocks, scientists can figure out how our solar system formed. They can also learn how meteorites have changed our planet. A Martian has landed. In 1984, meteorites hunters found a greenish rock in Antarctica. Scientists were shocked when they studied the stone. This was no ordinary meteorite. Tests show that the rock about the size of a potato came from Mars. How did a Martian rock land on Earth some 140 million miles, 225 million kilometers away? Scientists believe an asteroid or comet slammed into Mars 15 million years ago. The crash tossed the rock toward Earth, where it arrived only 13,000 years ago. Mighty meteors. When people say they've been a shooting star, what they really saw was a blazing meteor streaking through Earth's atmosphere. The ancient Greeks believed that flashes of lights were weapons of the gods. What they didn't know is that most meteorites are pieces that have broken away from asteroids, meteors, and chunks of comets and planets. Meteorites can do a lot of damage. Just gaze up at the moon to see the evidence. The many circular craters on the moon's surface are the result of millions of strikes by meteors and comets. Since there is no atmosphere on the moon, There's nothing to protect its surface from these flying space rocks. Luckily, Earth has an atmosphere that shields our planet. When a meteor collides with Earth's atmosphere, the fast-moving rock pushes air out of its way. As air particles move past the surface of a meteor at high speed, they cause the meteor to heat up and break into pieces. As those pieces burn up, the meteor glows in brilliant, fiery streaks of light. Then it vanishes as quickly as it appeared. Fireballs and meteorites. On February 2nd, 2012, residents of Amarillo, Texas heard a loud boom at around 8 p.m. When people looked up, they saw a blazing meteor light up the sky. What people saw was a special type of meteor that scientists call a fireball. Because some meteoroids are huge, they grow extremely bright when striking the atmosphere. In fact, some get as bright as the moon for a short time. What was the blast that everyone heard? The fireball was moving faster than the speed of sound, which is roughly 760 miles, 1,223 km per hour. As the object raced through the atmosphere, it shattered the sound barrier. Kaboom! The noise that shook Amarillo was a sonic boom. Sonic booms can be low, rumbling sounds or ear-splitting explosions. The noise can shake the ground and even break windows. Fireballs are rare. Micrometeorites are not. Most of these tiny meteors are smaller than a freckle. Tons of micrometeorites pass through the air and fall to Earth every year. Meteor showers. What type of shower won't get you wet? A meteor shower, of course. Meteor showers are brief periods of heavy meteor activity. They are fun to watch and you don't need an umbrella. Most meteor shows happen at the same time every year. They are often named after the constellation in which they seem to appear. For example, every November an Leonid meteor show appears in the same area of the sky as the constellation Leo. Hundreds, sometimes thousands of meteors can strike across the sky every hour. Scientists know when meteor showers will happen because they begin each time Earth passes behind a comet. As the comet closes in on the sun, it leaves a tail of dust and melting ice behind it in space. When Earth passes through the comet's tail, the dust burns up in the atmosphere, creating a natural fireworks show. Space gold. Scientists say an ancient meteor showers is the reason gold can be found in the rocks near Earth's surface. Why do they say that? When Earth began forming around 4.5 billion years ago, it was a big ball of molten rock. As Earth cooled, iron sank to the center of the planet, forming Earth's core. Some other metals, including gold, sank with the iron. If all the gold sank, scientists wondered, where do we find the gold to make watches, bracelets, and other items? About 650 million years after Earth formed, the firestorm of meteorites rained down. That meteor showers forever changed the makeup of Earth's crust. Scientists say so many meteorites slammed into our planet that if you put them all together, they would weigh about 1/4 as much as Earth's moon. Most of the gold we use for jewelry and coins came from those meteorites. Types of meteorites. Meteorites can give us clues as to how our solar system formed. Yet, not all meteorites are the same. Meteorites come in three main types. Nearly all meteorites are stone. Some stony meteorites come from the moon or Mars. A few contain small glassy beads, which formed under high heat at the time the solar system began to form. Iron meteorites come from the core of a long-vanished asteroid or planet. These meteorites are dark and look as if they are rusting. Iron meteorites are very heavy and sometimes have surfaces that look the way a lump of clay looks after being pressed all over with fingertips. Early humans made tools and weapons out of the iron meteorites they found. Stony iron are the last types of meteorites. If you find one, you're lucky. Stony iron meteorites are rare. As their name suggests, these space rocks are a mix of stone and iron. Meteorite impacts can be devastating. On land, a meteorite strike can create a gigantic explosion and powerful shock waves. Fortunately, the most destructive meteorite impacts happened long ago. Not only does Earth's atmosphere protect the planet, but the pull of the moon's gravity steers some meteoroids away from us. Dying dinos. Scientists say, however, that some 65 million years ago, one very large meteorite got through. At the time, Earth was home to many kinds of dinosaurs. After the large meteorite struck Earth, the dinosaurs vanished. Earth turned into a wasteland. Although scientists aren't completely sure, they believe a massive meteoroid or asteroid strike blasted the dinosaurs into extinction. Scientists say the impact threw huge amounts of dust, gas, and rock into the air. The blast changed Earth's climate, killing almost everything. Why do scientists say a meteorite was the cause? One possible answer comes from scientists who study layers of rock on Earth's surface. They noticed that at the same time the dinosaurs disappeared, the amount of iridium on the planet went up dramatically. Iridium is a metal that is rare on Earth but is common elsewhere in our solar system. The sudden increase of iridium in Earth's rock layers made scientists suspect that a large meteorite slammed into Earth, bringing a huge amount of iridium with it. Target Earth? The chances of another giant meteorite coming our way are slim. In 1908, a meteorite blew apart over the Tunguska River in Siberia. The blast leveled 400 square miles, 1,000 square kilometers of forest. As the meteor struck a city, the destruction would have been massive. However, we shouldn't worry too much. Scientists say chances are that a large meteorite will hit a major city only about once every 10,000 years. Asteroid mining. While some people see giant rocks in space as a threat, others see them as an opportunity. A company called Planetary Resources wants to send spacecraft to mine asteroids in space. According to the company, more than 1,500 asteroids orbit near Earth and could be easily reached using today's technology. Asteroids contain many valuable resources including precious metals and rare minerals. Asteroids may also contain a resource that's particularly valuable in space, water. Yet, meteors continue to fall and always will. If you look up in the sky tonight, you might see a meteor streak across the horizon as it ends its journey through space and time in a blazing show of light.